lecture, I'm going to define eigenvalues and eigenvectors of a square matrix. Before the eigenvalues and eigenvectors, let me define a characteristic matrix, a characteristic polynomial, and a characteristic equation. What is a characteristic matrix? Let us consider a square matrix over a field F. The matrix A minus lambda I varies the unit matrix of the same order as that of A, and lambda is an indeterminate, is called the characteristic matrix of A. So the matrix A minus lambda I, where lambda is an indeterminate and I is an identity matrix of the same order as that of A, is called the characteristic matrix. Then determinant of this characteristic matrix is called a characteristic polynomial. That is, determinant of A minus lambda I is called a characteristic polynomial, which is a non-zero polynomial of degree n in lambda, and that is in turn we call it as a characteristic polynomial. If that polynomial is equated to 0, becomes an equation, right? So we call that equation as the characteristic equation of A or eigenequation of A. Then the roots of that characteristic equation, determinant of A minus lambda I is equal to 0, are called the characteristic roots or latent roots or eigenvalues of A. Is this clear? So to find the eigenvalues of a square matrix of order n or any order of a square matrix, so we have to find the characteristic matrix, characteristic polynomial, and the characteristic equation. Okay, so with all those will be given by determinant of A minus lambda is equal to 0. So A minus lambda is called the characteristic matrix. Determinant of A minus lambda gives the characteristic polynomial. That polynomial, if we equate to 0, gives the characteristic equation, and if we solve that equation, we get the roots, and the roots are called as the eigenvalues. This is clear. So I'll take up one example here from which you will understand easily what are the characteristic matrix, polynomial, equation, and what are the eigenvalues. So here I have taken a 3 cross 3 matrix, which is a square matrix. 3 cross 3 means the order is 3, is a square matrix. So let us find out the eigenvalues. So before the eigenvalues, first we have to define the characteristic matrix, right? So the characteristic matrix of the given square matrix is of the form A minus lambda I. This is the characteristic matrix. If we take the determinant for this characteristic matrix, we get the polynomial. If we equate that polynomial to 0, gives the characteristic equation. So here, directly I have taken the characteristic equation. So this is enough. So let determinant of A minus lambda is equal to 0 is the characteristic equation. Is this clear? Okay. So once again I will tell you, A minus lambda is the characteristic matrix. Determinant of A minus lambda I gives the characteristic polynomial. If that polynomial is equated to 0, gives the characteristic equation. Okay, so let us consider the characteristic equation and we will find out the eigenvalues. That is determinant of 2 minus lambda, A minus lambda I. So A is the given matrix, lambda is indeterminate, I is the unit matrix. Here we have to consider the unit matrix of order 3 only, because A is a square matrix of order 3, hence we have to consider I is of order 3 only, right? So A minus lambda is nothing but the difference of the two matrices. Okay, how to find the difference two matrices? Just by subtracting the corresponding elements. So I will multiply it by an indeterminate lambda. Okay, then subtracted with A gives the elements of the new matrix as 2 minus lambda, 2, 1, 1, 3 minus lambda, 1, 1, 2, 2 minus lambda. So determinant of this matrix equated to 0 gives the characteristic equation. Okay. So let us find out the polynomial first, then we'll equate that polynomial to 0 and we'll solve that equation, right? So I'll find out the polynomial now by expanding this 3 cross 3 determinant using the cofactor formula with respect to the first row. Always expansion of determinant is nothing but using the cofactor formula with reference to the first row. Okay, so let us expand this determinant as we know. So here we follow the sign as plus minus plus, then the first element 2 minus lambda times determinant of a 2 cross 2 minor matrix, okay, which is 3 minus lambda 1 2 2 minus lambda. The next sign is minus the second element of the first row, 2 into determinant of a 2 cross 2 minor matrix, that is 1 1 1 2 minus lambda, plus 1 into determinant of a 2 cross 2 minor matrix, that is 1 3 minus lambda 1 2. Simplifying this expression by multiplication of the brackets, we get the final expression or the polynomial as minus lambda cube plus 7 lambda square minus 11 lambda plus 5. This is the characteristic polynomial. Now equated this polynomial to 0, which becomes the characteristic equation, okay, by multiplying by minus sign. We get lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. So this is nothing but a cubic equation, right? Now we know various methods to find the roots. We can use the calculator or we can factorize it by inspection, or we can go with synthetic division technique, that is trial and error method, okay, so that we get the roots as 13115. Since it is a cubic polynomial, hence we get the 3 roots, right? So lambda is equal to 115 are the required eigenvalues, okay. So this is the way, or this is the procedure to find the eigenvalues. It is a very simple thing. What we have to do is, firstly we have to consider the characteristic matrix as A minus lambda I. Then we have to find its determinant, okay, and we have to equate the determinant to 0, gives the characteristic equation, and finally we have to solve that equation. That's all. So let me take one more example. So in the second example, I have taken a 2 cross 2 matrix, that is a square matrix of order 2. Firstly, I have found a characteristic matrix A minus lambda I. Okay, here clearly I have shown matrix A minus lambda times unit matrix, then difference gives the characteristic matrix 3 minus lambda 2 minus 1 0 minus lambda. Then I have got a polynomial. Just I have found determinant of A minus lambda I, and then I have expanded, from which I have got a polynomial as lambda square minus 3 lambda plus 2. Then finding the characteristic equation by equating this polynomial to 0, and then finding the roots. Okay, so this is a second degree equation, quadratic equation, from which we can find the roots easily just by factorization, right? So from which we get the roots as 1 comma 2, that is lambda is equal to 1 and lambda is equal to 2. Okay, similarly you take up the example 3 and work on. Already I have done this also, I just go through it. So this is about the eigenvalues. Let me define eigenvectors. Let lambda be an eigenvalue of a square matrix of order n, then a non-zero matrix X of order n cross 1, so which means a column matrix, such that the matrix A minus lambda I times X is equal to 0. is called an eigenvector of A corresponding to eigenvalue lambda. So it's a very simple thing. So to find the eigenvectors of a matrix A corresponding to eigenvalue lambda, so we have to consider the matrix equation A minus lambda I times x is equal to 0. Okay. So here I'll show you the procedure to find the eigenvectors. So to obtain the eigenvectors x, so we have to consider the eigenvalue of A. Then eigenvector of A will be given by a column matrix, that is x is equal to x1 to xn of order n cross 1, which satisfies the equation A minus lambda I times x is equal to 0. Okay. So means we have to consider the matrix equation A minus lambda I times x is equal to 0, which gives Ax is equal to lambda x. So let me take a few examples. So here I have written a few properties of eigenvalues. Here I have considered a few problems. The first problem, find the eigenvalues and eigenvectors of the matrix A is equal to 1 minus 1 2 4. Verify the trace equals the sum of the eigenvalues and the determinant equals their product. Okay, so we will do the last statement at the end. First let us find out the eigenvalues and eigenvectors of the matrix. So as we know, to find the eigenvalues, so we have to consider the characteristic matrix, characteristic polynomial, then the characteristic equation. So directly what I'll do is I will consider directly the characteristic equation. Okay, let determinant of A minus lambda I is equal to 0 be the characteristic equation. Okay, which implies substituting for A minus lambda times I and subtracting, we get the new matrix as 1 minus lambda minus 1 to 4 minus lambda. Now find its determinant and equate to 0. So expanding this determinant using the cofactor matrix with respect to the first row, cofactor formula with respect to first row gives 1 minus lambda times 4 minus lambda, minus into minus plus, 1 into 2 is 2, which is equal to 0. Further, it simplifies to lambda square minus 5 lambda plus 6 is equal to 0. So this is nothing but a second degree polynomial or a quadratic equation. Solving this, we get the roots as lambda 1 is equal to 2 and lambda 2 is equal to 3 are the required eigenvalues. Okay. Since we have found the eigenvalues, so let us show trace of A is equal to the sum of the eigenvalues and determinant of A is equal to product of the eigenvalues. So this is a very simple task. So lambda 1 plus lambda 2, sum of the eigenvalues, that is 5. Then what is the trace of A? How to get the trace of A? Trace of A is nothing but product of the diagonal elements, right? Already I have defined. So trace of the matrix is nothing but product of the diagonal elements. Sorry, sum of the diagonal elements. Sum of the diagonal elements. Trace A is equal to sum of the diagonal elements. So 1 plus 4, that is 5. So sum of the eigenvalues is 5. Trace of the matrix is also 5. Hence trace of A equals the sum of the eigenvalues. So secondly, we have to show that determinant of A is equal to product of the eigenvalues. Let me find determinant of A. Determinant of the given matrix gives 6. Product of the eigenvalues gives 2 into 3, that is 6. So therefore, determinant of A equals the product of the eigenvalues. Okay. So let us find the eigenvectors of this matrix. To find the eigenvectors, so we have to start with a matrix equation, that is determinant matrix equation A minus lambda I times x is equal to 0. So here I have continued problem A. Yeah. Here I have continued problem 1. So we have got eigenvalues as lambda is equal to 2 and lambda is equal to 3. So let me find the eigenvectors. So we have to start with the matrix equation, that is a minus lambda I times x is equal to 0. So all of you are familiar with the matrix equation, right? So we have solved the linear system of equation using the Cramer's rule, right? So a minus lambda I times x is equal to 0 with the matrix equation. Then for the given matrix A, we get the matrix equation as 1 minus lambda minus 1, 2, 4 minus lambda times capital X is a column vector. Since we have a 2 cross 2 matrix, so we have to get only the two unknowns, which in turn are the eigenvectors, right? So capital X is equal to x1, x2 times 0. Okay, this is common for both the values, eigenvalues. Okay, let us denote this matrix equation by 1. So here two cases will arise. Case 1 when lambda is equal to 2, case 2 when lambda is equal to 3, right? So we will get the corresponding eigenvectors as x1 and capital X1 and capital X2. So the case when lambda is equal to 2. So putting this value of lambda in the matrix equation 1, we get the equation matrix equation as 1 minus 2 minus 1 minus 1 2 2 minus the 4 minus 2, that is 2 times of x1 x2 is equal to 0. Okay, so simplifying this matrix equation, which reduces to the two linear equations, we can say the equivalent equations are minus x1 minus x2 is equal to 0, 2x1 plus 2x2 is equal to 0. These two equations yields to a to the same equation, that is x1 plus x2 is equal to 0, right? So which can be taken as x2 is equal to minus x1, or we can consider this as the ratio x1 by x2 is equal to minus 1 by 1, so that we get x1 as minus 1 and x2 as 1, so which gives the value of x1 x2 and in turn gives the corresponding eigenvector. So representing the values of x1 and x2 in the column matrix, that is x1 capital X1 is equal to minus 1 1. So are the corresponding eigenvectors of the eigenvalue lambda is equal to 2. Similarly, let us find the eigenvector corresponds to lambda is equal to 3. Now putting lambda is equal to 3 in the matrix equation 1, 1 implies minus 2 minus 1 2 1, x1 x2 is equal to 0 0. Okay. Now this gives the equivalent system of equations as minus 2x1 minus x2 is equal to 0, 2x1 plus x2 is equal to 0. These two equations it's into a single equation as 2x1 plus x2 is equal to 0 or x2 is equal to minus 2x1. So which can be written as x1 by x2 is equal to 1 by minus 2. So ratio of x1 x2 is equal to 1 by minus 2. So x1 is equal to 1, x2 is equal to minus 2. So therefore the corresponding eigenvector for lambda is equal to 3 is denoted by x2, which is equal to 1 minus 2. So this is how we can get the eigenvectors corresponding to the eigenvalues by forming the matrix equation. So let us consider the second example. In the second problem, here I have taken a 3 cross 3 matrix of order 3. Let us find first the eigenvalues, then we will find out the corresponding eigenvectors. So as usual, we have to find the characteristic equation, which is given by determinant of a minus lambda is equal to 0, expanding the determinant. See, here we can use the property of determinants, right? One of the property of determinants, because all the elements below the principal diagonal are zeros. So therefore, the value of this determinant is the product of all diagonal entries. Okay. So this is an upper triangular matrix, we can say, right? So its value is the product of all the principal diagonal elements, that is 3 minus lambda into 2 minus lambda into 5 minus lambda, which is equal to 0. So no need to simplify because we have product of 3 linear terms. So we can find the roots directly by equating each factor to 0. That is 3 minus lambda is equal to 0, 2 minus lambda is equal to 0, 5 minus lambda is equal to 0, which implies lambda is equal to 2, 3, 5. So are the required eigenvalues. Let us find out the corresponding eigenvectors by forming a matrix equation. Let A minus lambda I times x is equal to 0 be the matrix equation, which gives here the given matrix is a square matrix of order 3. So we have to consider the identity matrix of order 3 and x column vector, okay, of order 3 only, okay, which consists of the unknowns x1, x2, x3. So we call these unknowns as the vectors, right? So x is equal to x1, x2, x3. So this is the matrix equation. We can denote this by 1. Let us consider the cases. When lambda is equal to 2 is the first case. This matrix equation will reduces to 1, 1, 4, 0, 0, 6, 0, 0, 3, x1, x2, x3, 0, 0. Okay. Now let us simplify this. We get the system of equations as by multiplication, right? By multiplication, we get the system of equations, or we can say equivalent system of equations as x1 plus x2 plus 4x3 is equal to 0. Since here first two entries are 0, so 6x3 is equal to 0. In the last row also first two entries are 0, so 3x3 is equal to 0. So here to find x1, x2, x3, we have to consider, so it is enough to consider any two equations. So obviously we have to consider the first equation and the second equation, or first and third. Okay, any two equations we have to consider to find x1, x2 and x3, right? So solving of equations, already we know various methods to solve the linear system of equation. Here we can use the Cramer's rule or the trial and error method, or rule of cross multiplication. Okay, so here I have employed the rule of cross multiplication. Okay, so I have taken the first and the second equation. In the second equation, the coefficients of x1 and x2 are zeros. So here I have written the RCM, right? So to find x1, x2, x3, I have to consider all the coefficients. Okay, that is first, second, and third coefficient. Then again, I have to repeat the first two. Similarly, I have written all the coefficients of the second equation. Then again, I have repeated the first two coefficients. Okay, so let us cross the first row or the first column. Then I have applied the cross multiplication. Okay, so this gives the value of x1 divided by ratio 6 minus 0 plus x2 divided by 4 minus 6, which is equal to x3 divided by 0 minus 0. See, I have shown the arrow mark. This is how we have to do the cross multiplication. Okay, so this simplifies to x1 by 6 is equal to x2 by minus 6 is equal to x3 by 0. So in order to get the value, let us equate all these ratios to a common constant. Let it be k. Here we have a common term, that is 6. We can cancel it. So multiplying the entire ratio or entire equality by 6, which reduces to x by 1 is equal to x2 by minus 1 is equal to x3 by 0 is equal to 6xk. 6xk is a constant, let it be k1. Okay. Now equating each ratio to the same constant and finding the values. So this is a very simple task. Easily you can do it. So x by 1 is equal to k1. x1 by 1 is equal to k1 gives x1 is equal to k1. Similarly, the second ratio equated to k1, x2 by minus 1 is equal to k1, x3 by 0 is equal to k1 gives the required values of x1, x2, x3 as x1 is equal to k1, x2 is equal to minus k1 and x3 is equal to 0. Here we can choose the value for k1. Okay, so k1 as 1, minus 1, 2, minus 1. Okay, otherwise we can keep k1 as it is. So let us keep k1 as it is and let us write the corresponding eigenvectors in the form a column matrix, right? x1 is equal to x1, x2, x3, or we can consider it as transpose of x1, x2, x3 also. Okay, so substituting and taking k1 as common, 1 minus 1 0. If you want, we can choose k1 as 1 or minus 1 or any value k1 take. Okay, next let us obtain the eigenvector corresponding to the second eigenvalue. So the second eigenvalue is lambda 2 is equal to 3. When lambda is equal to 3, the corresponding eigenvector. So substituting lambda is equal to 3 in the matrix equation, the above matrix equation, which reduces to 0, 1, 4, 0, minus 1, 6, 0, 0, 2 into x1, x2, x3, 0, 0, 0, which implies the equivalent system of equations are x2 plus 4x3 is equal to 0. Multiplying these two matrices, we get the equivalent system of equations. x2 plus 4x3 is equal to 0 minus x2 plus 6x3 is equal to 0, 2x3 is equal to 0. Now again solving the system, here we have to consider any two equations. Okay, so let me take the first two equations. I'll apply the rule of cross multiplication. Here I have shown rule of cross multiplication, so that x1 by 6 plus 4, that is 10, x2 by 0, x3 by 0. So we get the ratios as x1 by 10 is equal to x2 by 0, x3 by 0. Let us equate these ratios to a common constant, and then we can find the values of x1, x2 and x3. So which gives x1 is equal to k2, 0, 0. Here 10k, I have removed this 10 by multiplying through by 10. So 10k, let it be another constant k2. Since we are in case 2, so the constant after k1 we can have k2 or k1 dash also we can use. So k2, then x2 gives x1, x2, x3, that is k2, 0, 0. Okay, if you want you can take k2 as 1 or minus 1. Okay, choice is yours. So for lambda is equal to 3, the corresponding eigenvectors are x2 is equal to k2, 0, 0. Okay, so let me find for the last case, when lambda is equal to 5, the matrix equation will reduce us to minus 2, 1, 4, 0, minus 3, 6, 0, 0, 0. x1, x2, x3 is equal to 0, 0, 0. Now multiplying this, we get the system of equations, as since the last row is 0, hence we get only the two equations. There is minus 2x1 plus x2 plus 4x3 is equal to 0, 0x1 minus 2x2 plus 6x3 is equal to 0. Solving using the same rule of RCM, rule of cross multiplication, we get x1 by 18, x2 by 12 is equal to x3 by 6. Let us equate all these ratios to a common constant. Since in the denominators we have the multiples of 6, so we can multiply throughout by 6, gives x1 by 3 is equal to x2 by 2 is equal to x3 by 1, which is equal to 6k. Let 6k is equal to k3. Now equating each ratio to k3 and finding x1, x2 and x3, we get x1 as 3k3, x2 as 2k3 and x3 as k3. Therefore the corresponding eigenvectors for lambda is equal to 5 is a k3 times 3 to 1. So here also we can take k3 as 1 or minus 1. Okay. So this is how we can find the eigenvalues and the corresponding eigenvectors by forming the matrix equation A minus lambda is equal to 0. I have so many problems from Gilbert Stein, which is the reference textbook. I have worked out. Please go through it.